Bismillah ar-Rahman ar-Rahim. We had a discussion on the 11th of November 2024, and you can see the title. This discussion was under the supervision of me, Muhammad Anwar Rifky, and Dr. Sana Ahmed, and Dr. Marwa. And this is the hint about the summary of this thesis, if you want to have a look. And you can see downwards the conclusion of this study between the two groups, whether they were the group belonging to the conventional para-vertebral block or the group related to transverse process, mid-transverse process pleura block. These are additional information that I had taken from the internet, where we can see from the first point that whenever you have an uncomfortable sitting for a block, you can shift really to what we call the mid-transverse process block or the rectospiny block, so that you can be away from the pleura. Of course, the block can be done in the sitting lateral or prone position, where you use it 80 millimeter 16 gauge Tohi needle inserted at the angle of 90, 3 centimeters lateral to the midline of the spine. And then whenever you contact the transverse process, you will walk up whether caudally or cephalic to reach to the superior costo transverse ligament, where you can pierce and reach to be near to the pleura. Of course, some people, of course, use what we call the landmark technique, where you use a syringe filled with air, and then you go through the anatomy, as we had said before, to feed the pop or the click. This click, of course, the pop is not it's subtle. It's a very weak one, not like the one we appreciate whenever we do an epidural block. So we ought to be cautious whenever we do the technique. Otherwise, we can injure the pleura. Of course, these are the three nerves supplying the breast. Whenever I want to block, I ought to block all this, especially if we are going to remove lymph nodes from the axilla, where we can use what we call the pectoralis 2 or 1 block. The paravertebral space, of course, it can be reached by a nerve stimulator. Whenever I stimulate nearby the space, paravertebral space, I can appreciate the contraction of the rectus abdominis muscle with around 1.5 milliampere. So whenever the needle is nearby to this space, I can elicitate this contraction with only 0.5 milliampere. Whenever I reach this, I can say that I am nearby the target of block. The space has a low pressure. Whenever I measure the wave pattern, I find it is smooth and regular. Dextromethylmidine or magnesium sulfate can support the local anesthetic use, but we must put in our consideration that dextromethylmidine may induce a hypotensive and bradycardial effect. Many authors found the space very difficult to reach. So it is a complex region, and it's deep. So you ought to have a proper resolution. So it's difficult to use props to go deep or having a good resolution. So it is not as simple as we think. The 9th point is that we can block what we call the serratus anterior block, so to supplement the complete block of the breast whenever I'm going to remove, suppose, the axilla. And I don't want to go to deep details about the serratus. You have the probe and you have the anatomy and you have the landmarks where you can reach to the serratus anterior block, where it takes a shorter time to perform, and it is a way or by proxy to the paravertebral block. The block, of course, takes around, this paravertebral block takes around from 4 to 9 minutes. The point is, whenever I use a local technique, I'm devoting, I'm making the patient away of giving general anesthesia. Thus, I am maintaining the pre-operative immune function. This was reported by authors. We have what we call the retrolumbar laminar, block. This will be shown in a figure where I just reach to the backwards of the lamina and deposit the local anesthetic. Of course, this is a lock where this local anesthetic can spread, reaching to the paravertebral space through fenestrations and openings in this superior costo transverse ligament. This is the point, or how does it reach? Of course, we can support the block, by many drugs, including what we call the dextroisomer of ketamine. But it didn't reduce the paroxysmal nocturne dyspnea occurring with ketamine. This is the hint out to how to block the pectoralis nerve stage 2. It is where the local anesthetic being injected between the pectoralis minor and the serratus anterior muscle. And sometimes you can go further between the serratus anterior and the latissimus dorsi. All these are ways to support the paravertebral block whenever I want to extend the block. Of course, it goes. The effect is going to block the nerves through the upper intercostal nerves. Of course, they found the addition of 5 milligram of epinephrine to levobupivacaine minimize its toxicity. I'm sorry. Of course, any local anesthetic can be enhanced by using what we call the liposomal bupivacaine, which is bupivacaine encapsulated in a lipid layer. This gives a slow release of the drug so that it will take a longer time. And reported cases, of course, whenever I use any local technique, this spread can reach, in some cases, causing Horner syndrome. And a fatal accidental subarachnoid block had occurred, so you must be cautious whenever you apply this paravertebral block. Of course, the continuous block, as we know, whenever I want to add a catheter through this space, this continuous can lead to toxicity. Sometimes once happened that the surgeon administered the epidural catheters by himself, and the patient, it was a continuous method, and the patient developed later on quadriplegia. So they were surprised. So whenever they did an X-ray, they found that the catheter was intrathecal. So you must put in your consideration all these complications that could occur whenever you do a paravertebral block. Some authors use the paravertebral block in a high concentration to achieve a complete anesthesia without using general anesthesia in elderly compromised patient, and found it with some sedation a successful way. And this is how we induce the pectoralis 1 block, where we administer the drug between the pectoralis major and the minor. See, so we have pectoralis block 1 and 2. This is a nice figure. Gestures mean that you are using your hand to give a hint about something. So these are the two methods to block the paravertebral block, whether you are using sagittal way or a transverse way using the probe. And this is the figure where we can see the difference figures between the transverse and the sagittal. And this is the final picture. So it looks like the hand, whenever we use this method, I use my two knuckles as if to show to my learning colleagues that I'm using this way to block, or I can use my finger in this way to show that the area I'm going to be blocked. It looks like that while I'm using the ultrasonic sonic method. And these are some figures showing, first of all, this is the superior costotransverse ligament, where the ligament is being attached to the transverse process and the rib. And this is the different types of block, or we call it by proxy to the paravertebral block, to reach nearby, you see. And this is how we count the vertebrae. Of course, we know the uppermost part of the neck can be shown by the cervical 2. And then we know that the lower border of the scapula is around thoracic 6. So these are the landmarks we use. And this is how does it look whenever I go. That's the two processes of the transverse processes. And then we can see the hyperechoic effect of the lung. And whenever I inject saline before injection, I can see the dip of the pleura by the saline injection before giving the local anesthetic to show that I didn't pierce the pleura. And this is a color picture showing the superior costotransverse ligament, and below it we can see the paravertebral space, and we can see the transverse process on either side. And these are the needles used. You need around 80 millimeter needle to block to reach to the proper size. And this is what we call the mid transverse process pleura. This is the area midway between the pleura and the transverse process. This is one of the methods to be used. Of course, it is away from the pleura, giving more safety. And this is how do we block the pectoralis nerve. Pectoralis nerve, and this is the nerves nearby. The colleague used what we call the Mann-Whitney test. This is a test to compare two data. As we can see, suppose we have these are the data on both sides, 3, 4, and so forth, and this on the other side. We use what we call the rank system. Rank system means that I'm going to rearrange these numbers according to their level. In other words, suppose I'm going the least one among this, suppose it's going to be 2. So I'm going to replace 2 by number 1, and after that it will come 3. I'm going to replace it by 2 and so forth. So this is ranking. We are ranking. So the both sides are being ranked, and this is the final sum. This is the word sum, and then I'm going to choose the list of them, and then I go to a use statistic test where I apply what I had done, and he's now applying the list number. He's going to subtract it from the number. This is the number of the total, and then he's going to subtract or add 1 and divide by 2 to reach to a certain number. This certain number is going to go to a special table. This table has rows and columns. So the magic critical value, which is 0.025%, will be figured out, and then compare it to the figure I had reached, and then if it is less, it means that the relation between the two data is significant. So we will reject what we call the null hypothesis. Null hypothesis, that there is no difference between both groups. But if I reject, we can call it that it is significant. This is a nice, of course, T student test. A nice thing about it, whenever you remember the history, it was induced by William Gossett. This Gossett was asked to compare two fields of barley اللي هو الشعير, and then he wanted to give his idea to his colleague statisticians. So the Bureau genus company refused. They didn't want him to share with others. So they had to call it this student test. So simply he is taking samples from field 1 and 2, and then he draws what we call a bell curve. This bell curve is made of different histograms. So whenever I do different histograms, I can make what we call the two bell curves. Or if you see both of the two curves, suppose you can see that the mean, which is the number of the data divided by the number of them, you can see one of them is more than the other, but it's not all the story, because this curve can be either in a length way or in a broad way. So this is not the story. So whenever I have two data, I reach to a conclusion where I calculate, of course, this is how to calculate the standard deviation. Standard deviation means that how are we spreading away from the mean. So this is the simple or the simple equation where we show the standard deviation where we can figure it, and then we put it in a special equation, as we can see. This is called the t value. This t value is being, as we can see, I put all the figures that I had from this, and I reach it final to this number. So this is the t value, but it's not the t test. The t test is taking this number to a special table. This table has, as we said before, columns and rows. So I reach to the column where I find the magic critical value, which is 0.025 from the table, and then I cross on the row what we call the degree of freedom. Degree of freedom is the calculation of both groups. It were 32. I subtract 2 from both of them, and will reach to a number of 30. So I put on the I reach to the column of 30, intersecting the column of 0.02, where I reach to the number. If this number is below the critical value, this means that the relation between both data are critical. If it's bigger, so the relation between the two data are non-significant. No, there is nothing to be found. This test is called unpaired. Unpaired because sometimes you do what we call pair test. You must understand each of these abbreviations, titles. You see, this is what we call two pair test, where I am comparing the two data, but meanwhile in one of them I'm comparing both of my results in one field. Suppose I'm going to take a sample of the same field without a special fertilizer, comparing it with another group with a fertilizer. So I'm doing two things in one of the groups. So this is what we call a pair. So the test I had been discussing later on, it was unpaired. Now this is the curve where we call it the bell curve. This bell curve has two ends, tails. These tails each of the calculation, both of them is the 0.025%, and most of the data has been spread in the 95%. See, this is a hint about the t-test. This is what we call the chi-square test. Chi is the 22 letter of the Greek alphabetic. How it looks like an X, but one of the lines of the X is being inclined. So the equation is, as we can see, observed minus expected over expected. What's the meaning of that? Of course, if I flip a coin 100 times, I will say to myself, okay, most of them, 50 of them are going to be, I'm sorry, I'm trying to remember. One of them will be a king, and the other one will be the opposite of it. It's a written letter. So we have two parts of the coin, you see. So logically, I'm going to say that if I made it at 100%, 50 of them will be one of the types, and the 50 the other will be the other type. So this is the expected. But if I throw the coins 100 times and then I figure it out, I found that the tails, I'm sorry, we find that the figure was 62 head, I'm sorry, it's called head, and 38 tail. See, you have this figure. So this is not, as we said before, the expected one is 50-50. So I put this figure in the equation, as you can see, reaching to a number. This number, I go to a table, go to another, the same table. This table, of course, as we had a column and rows. This table has, of course, the color, the rows is depending about the degree of freedom. So we have two results. So either tail or head. So we minus one from the two. So the degree of freedom will be one. You see, why did they call it degree of freedom? Because suppose I tell you the number 10 divided into three divisions. You're going to say, suppose the first number I'm going to choose 6, and the second one I'm going to use suppose 3. The third number I am forced to use 1, otherwise it will not reach the 10. So this is why we are saying that the first 2 numbers I'm free to choose, but the third one I'm obliged to take a number for them to be 10. So this is the table, as we can see, and we reach to the magic critical value, as you can see, 0.05, and we put intersection, we'll reach to a number. This number is going to be compared with what we had seen, the 0.72. If it is less than the critical, so the difference is not significant. In other ways, there is nothing wrong with the coins, and there is nothing wrong with the way I'm flipping the coin. You see, so this is the chi-squared test. The last test, he used what we call the Fisher exact test. It's nice to memorize the story. Fisher was in a party, and the party, one of the females told him that I can tell you whether the cup of tea was first of all poured, the milk was poured from the first beginning or after putting the tea. So he began to think how to use this claim to prove whether it's right or wrong. So this is a small figure showing that we have a male and a female numbers, and we have each of them are being subjected to two types and of drugs, and these are the numbers of the males and the females according to the subjected drugs, and they are being put in a cell. So this as we can see, this test If you are using more than 20, each of these cells ought to be if it's less than 20, I'm sorry, the count ought to be 5, not more than 5. So here is more than 5. So the test is being held by that I'm trying to, I'm trying to change the results so that I'll yield different p values, and all these p values are being put in a special figure, and seeing is this p value less or more than the magic critical value. This is the last figure showing, suppose I have a box, and this box has 4 balls. We have 2 orange and 2 green, and they are numbered, you see. So if I tell you if I take 2 balls, how many different types of possibilities I will have. Of course, as we can see, we have 6 possibilities. We have one type possibility to have 2 orange, or one type to have 2 green, and then we have 4 expectation to be 2 different colors. So this possibility, in other word, the 2 green is 1/6 of the ore. So these are being put in the equation, as you can see, and this equation will reach to a special figure. This is how they use the Fisher exact. The nice thing about the Fisher exact that I am not in need of the degree of freedom, and I'm not in need of having tables. I hope that I gave you a hint about this discussion. Well, I hope to see you later on. I'm going to hold, of course, another thesis about anticipated difficult intubation and fiber optic support with different types of sedation. Wassalamu alaikum wa rahmatullah wa barakatuh.